All right. I guess it's time we should begin. Um, Please jump into the meeting minutes, add your names, add any topics. There's a link in the chat box. If you can't access it, send a ping, send an email, just say something, and we'll make sure that you do have access. Moving on. All right, Abhishek, you're up.
Hi. Am I audible?
Yep, you're audible.
Good. Great. Yeah, so I guess today we'll be looking at the progress of our SMI conformance to integration. So our target was to bring out the results to the UI. Let me share my screen so that I can show a demo of our progress. Yeah, is my screen visible?
Yep, it is.
Great, nice. So as you can see, I've just booted up the Meshery UI in which I've configured my cluster and I've also configured my uh, adapter. Basically, I'm running on a Kuma adapter right now. And yeah, so let's begin with the test. So basically, to run the conformance test, you'll have to go here and then press on validate conformance uh, option, and that would internally in the background begin the test. And so this test would approximately take around like good 10 minutes. So
And
I'm going to have,
Abhishek,
yeah,
actually, that's okay, man. We don't need to your point, we don't need to necessarily spend 10 minutes, but if you could kick it off now so that we can see that it works later. Okay.
so basically I have a history of results that I've run previously.
Yeah, no, I
So
guess what I'm saying is I'd really like to see it run end to end. Like if you kick it off now, we could come back toward the end of the call.
yeah, sure. I just
That's great.
kicked it off and I can see the system been running.
Cool.
So let's so until then I'll fill the gaps basically to uh, until the test comes back, test results come back. So basically, when the results come back, it would be a notification in here, and that the results have been persisted in the Meshery server, and each of the test result would look uh, something similar to this. So each of the result would be a single row in here, and ID you see is the test ID that corresponds to the test, and so basically, if you click on it, so so right now we've not worked on the CSS bit yet, so this looks a bit shabby. But the the summary is that we have brought the results in here, and basically, if you look at that, as we discussed last time, Lee, so the tables and the values have been properly inserted here, and there is another PR that is corresponding to the missing columns. So that's yet to be merged. So if that is in, then yeah, this process would be completed. And yeah, so basically this is the overall idea of what we're going to achieve here. And uh, so if you look at the columns, it shows you about every detail, when the test has run, and what is the mesh version, and the mesh name on which it ran the test, the percentage of the conformance. Basically, uh, we run several test cases over different specs of SMI, and the percentage pass would evaluate the rate of conformance of that particular service mesh. To view more details, you can click on this drop down here so that it will give you more details on each spec that it ran on. Basically, we right now have three specs on which we run the conformance test, and yeah, so that's pretty much all the details. And we should see the missing columns here, in which The data is not present yet, but that PR is actually in place, and it should be shortly be coming out.
And just to note, this were the previous tests which Abhishek ran
Yeah.
before.
So in a couple of minutes, the test that I just ran should come up as another result, as another row in here. So until then, yeah, I guess Lee should we fill it with something else, fill the gap.
Or yeah, maybe feedback or questions from others about the functionality.
Yes. Yeah.
If that's what you're asking, I have a question while others are coming with theirs. There's your you're demonstrating this in context of Kuma, but hold on one sec. Oh, oh, that felt good to get that out. Excuse me. Oh, there might be another one coming. Hold on. But none of the changes here are Kuma specific, correct? Like
Correct. Yes. So everything is wrapped up. All the logics have been wrapped up inside the toolkit, and the other logics, I mean, the parameter calculations and every other stuff have been wrapped up inside the SMI conformance tool itself. So while bringing the data to the adapter, it's just a proxying of data. So there is no manipulation involved in between. So it's a generic one.
So let me take some liberties here. One is I think I was hanging out on the Google Meet, and I'm gonna quit that because it's really distracting. But I wanted to make sure that anyone who accidentally joined there got redirected. So I think we're good. Because I'm excited about folks like Pratik who are on the call, who are kind of relatively fresh, and Shubham, whose audio is just about to come on. Hey Shubham, we were just kind of waiting for you to join. Sort of.
Hello, sir.
Hey, I'm just, hey, thanks for jumping in. So Pratik and Shubham, I wanted to make sure that you guys feel really warmly welcomed, because we already harassed Josh, I think, last week, like almost the whole call. So Mr. Ike already feels really welcomed, I hope. I wanted to make sure that everyone had the right context for what Abhishek and Dhruv are showing here. This has been a work in progress from Kush and Naveen and Kanishkar, from a collection of people. And I might have missed some people in that, but very briefly, Meshery interacts with 8 different service meshes, a lot. I'm got my fingers crossed that maybe before the end of this month, that we would interact with a 9th. There was a new service mesh that just was announced yesterday, that we'll talk about on the community call. The more of these things that there are, the more call for standardization that there is. One of those standards is service mesh interface, this abstract set of APIs to have a single API that rules them all. It's like one ring to rule them all, one API to rule all the functionality of the service meshes. And as each individual service mesh project goes to conform to that standard API, they may or may not implement all of the APIs. Or if they do, they might implement the behavior that service mesh has might be divergent from the specification of the API. And the effort that the community here is giving is to validate or confirm conformance of each individual service mesh's implementation against that standard. And in this way, Meshery, that effort, it's a good effort. It helps a lot of people, a lot of projects. It also makes Meshery the official the tool for officially verifying this conformance. Yes, it was, Neil. Nice job. And so anyway, that's the context for what these guys are doing. The UI, we're like, I would say that they're at version 1.5, if you will. Like really, it's kind of when we get to version 2 of this capability that we will be asking and engaging with each of the service mesh projects to use Meshery to verify their conformance. There's kind of a V3 of this, a re-architecture of how the tool works. But when we get to V2, when these guys tie off this last bit, we'll be pretty good to go. Given that context, so Pratik and Shubham, I was sort of calling you guys out to make sure that you were paying attention and you had kind of a understanding of what's going on. I know Shubham, you didn't get to see the demo just now, so this is not a fair question for you, but just, you know, Pratik as a way of like kind of breaking the ice, so to speak. In any feedback that you have of what you saw, kind of I know it's just an unfair question, but like anything that you saw that like wasn't really maybe presented in the most understandable way, or wouldn't have been intuitive to you as a user to run this set of tests to verify conformance? And if the answer is, I have no idea what you're talking about, that's perfectly fine. But does anyone else, maybe open up that question, anyone else have feedback? Questions maybe, just to clarify what's really going on? So part of the, yeah, sure, totally, Pratik. It's a totally unfair question. The part of what Dhruv and Abhishek would, hopefully you guys, about how far away do you think you are from kind of completing V2, if you will? That meaning that you still wouldn't yet have results available and persisted on the left-hand side, but I guess just a fairly high confidence that when you invoke a set of validations here, after 10 minutes or so, you'll get the results back. If the user was on a different screen, they'll see the notification come through that says results are complete. I probably missed it, but do we navigate them over to the specific service mesh, the specific adapter that those tests were invoked from? Is that where they see the results?
Yes. So basically, it's not the data that is being stored in the backend. It's irrespective of the service mesh. So irrespective of the view on which we are in, we will be able to see the results according to the adapter, because it's at the end of the day, it's just a filter that we apply to view the results.
Got it. So even now, like if you navigate over to Open Service Mesh and you click on View SMI Conformance Results.
So you have the Kuma results in available in here, but
right
we
now
will,
the local host of OSM is Kuma itself. That's why it is showing Kuma over here.
because we don't have the OSM attached.
Got it. Oh, I see.
It is checking with the adapter name itself if the name are same for all the adapters and filtering through.
So it compares the running adapter's name with the adapter's name in here, and then based on that, it will display the results.
Nice. Makes sense. Do you guys want to speak to some of the last standing changes that you've got going on? It looked like kind of that secondary table. There was some formatting stuff you're working on.
The
So,
CSS is left, but what I guess you can do is you can comment on the layout of the things if you want to change it.
Briefly, like a lot of this is obvious. I know this is a work in progress, so it doesn't really help to like. So just if you go back, if you minimize the table, you kind of go back to the ID. Just these things, I'm sure that you guys are already all getting to, but it is good to kind of just let people know that these are individual, like to show them the ID column. That's probably, we might just curtail that to like 5 or 6. We might truncate that.
Sure, yes. Yes, we might be able to do right.
Yeah, the ID, the timing itself in the detailed version, that were two things which I had in mind. Other than that, if you have anything in mind which we need to truncate till right now.
And that truncation, by the way, Abhishek, would just be client side. I mean, the UUID would still be, the ID would still be the full thing, but just what we're displaying to the user might be
Yeah, totally. Yeah. It makes sense, actually.
inside. And so I understand that, hey, under the percentage passed, you'll have an aggregate number that says, of the 30 something tests that you're at 70% pass rate or what have you. That's great. Here's your service mesh. Here's the version that it was done. It might be that, and I now I can't remember quite what was in the mock-up, but it might be that it's appropriate to show the SMI version that this test suite was run against.
Basically, I moved the SMI version inside and here because the issue is that, let's say if we are running traffic access for alpha 1 v1 and we are running traffic split on something else like beta 1 v1, then that it's specific to the spec rather than it's specific to it's not specific to the test. So that's why I moved it inside.
Got it. Makes sense. The rest, like, I don't think I need to speak to you guys are, I mean, with you guys have the right UX paradigm of a kind of a table in a table with additional details, and you'll work on cleaning up the rest.
Great, nice. So we have got the
Perfect.
results and we have the result ID in here. So the idea was to have an on-click character in here to directly navigate it to the table. And that has not been implemented here because it's not been discussed yet. So if you look at the results, you would have an extra one. Oh, it's just 1 to 2. 1 second. Oops.
My apologies once again. Is it possible just to quickly recap what was been discussed here?
Sure, yes. Just a bit. I'll just put up the screen to show you the results. I'll come back to you on it. Yeah, sorry, got crashed. So I forgot the ID. I guess this must be the one. Not quite sure which one was it. So yeah, you can see we got 3 of the results in here. So the one that we ran just now came up.
Nice.
I guess this one is the one. Yeah, I guess this is the one.
Nice. Cool.
Great. To summarize, what we have been done until now is that I was demoing something of we have a semi-conformance test integrated in here. So I was doing a demo, giving a demo with the chroma adapter. Basically, when you do validate a semi-conformance test, the test begins, and in the background it runs for almost like 10 to 15 minutes, and then it comes back with the result in the notification in here, and then that is being persisted as one of the results that we run inside a table. So that table would appear when you click on this chip, and this table would give you a detailed description of what exactly the test that was done in the background. And so if you click on any one of them, you would get the test and the assertions that ran inside. So basically, on every specification, SMI specification like a traffic access, split, or spec, and how long it ran for, and there are a couple of missing parameters in here which for which we put a PR, and that is to be done by today. So yeah, so those parameters will also get filled. So basically, it will show you all the capabilities uh, and all the results of how conformant the mesh is with the service mesh interface. So yeah, so that's pretty much what I have demoed in here. So if you're wondering what SMI is, then it's basically a set of specs that that any service mesh could use to sort of develop their own service mesh. And so these specs are nothing but a set of CRDs that facilitate to build a service mesh. So that's pretty much the gist of what SMI is, and we are just running a test to make sure or to test if the service mesh is conformant, how conformant is the service mesh uh, with SMI.
Hi, Lee. The link which you have sent across, that is in the shared dice of layer 5, correct?
Yep, it is.
Okay, thank you. Fantastic.
Yeah. Yep. And just as we go to wrap this up, I think the SMI as a project, they meet twice a month. As it so happens, today is the day that one of those meetings happens. So they meet in about 2.5 to 3 hours from now. And so Abhishek and Dhruv, depending upon how far you can get in the next couple of hours, it might be that a redemo, kind of a demo at that meeting might make some sense.
Yeah, sure. I can fix the alignment by then, and if Abhishek is able to fill on all the data which is left, then I guess we do it.
We'll work on the PR, and it's already up, so we just have to merge it and test it out.
Okay. And if it's too tight, we can give it a, but yeah, that's good. That's good. Fair enough. I suspect there isn't any additional feedback. Nice work, guys. We're almost there. It is time for us to engage with a couple of with the Kuma team as a good example. They're aware of this effort. I've messaged with them recently. I'll go ahead and initiate a mail thread with the Kuma team actually, and see if we can have them start to test it out. Cool, that's good.
Yeah.
Back to you, Shri.
Hey, all right. Moving on to the next topic. Dave, I think you're up.
Yep. Hey, hi everyone. Let me just share my screen. Is my screen visible?
Yep, it is.
Okay, then let's start with Go plugin. Yeah. Okay, so in this presentation, I will be talking about Go plugin, a tool built by Hashiko. It's an open source project. So uh, before that, I will like to give some context about plugins and little detail about them. So first, I would like to talk about how can we build pluggable apps. So pluggable app is nothing but an extensible app. For example, your browser in which you can add extensions, something like that. Okay. So some terminologies that I will be using: host, A host is nothing the main app, the main process, for example, browser, and plugin is nothing but an extension. And interface is basically a definition of something, like a collection of methods or something. Okay, let's just go ahead. Then yeah, how to build pluggable apps. So a simple and intuitive approach is, let's create an interface, collection of methods. Our host will just call those methods, and our plugin will implement them. Now, okay, so yeah, we implemented our plugin, we implemented the interface. Then how we are going to add that plugin to our host? Okay, so one approach is that yeah, we will just implement that in a new file, and we will add the file to our host code, so that host will directly will can just load the plugin code and directly access the methods. That's one approach, but there are some pros and cons related to it. Yeah, it's beginner friendly, essentially, but a plugin developer will do it. He will just implement the interface. Easy to install. We just have to copy and paste the file. But there are some cons like language, for example, language constraint. So if the host is written in Go, then we cannot use any other language, for example, Python or some other language. We have to write the plugin in Go itself. Another is stability. So what do I mean by stability here? So for say our host uh, our host will work fine if there was no plugin. Means what I want to say is, if there is some error in plugin, and our code will just the panic will the plugin will panic, and our host will panic with it. So that's an issue, because I don't want that. Okay, some a user has added some plugin, and because the plugin was panicking, my whole program just crashed, because my host may be running other plugins, and maybe it was doing some other work too. So I don't want that. So next approach is plugin as a process. So what we can do is, we can just it's what we can do. So our host will be one process, and our plugin will be one process, and they will be talking over some network, say some TCP connection or something. And the idea here is same, that we are using interface because yeah, we want to have those things like beginner friendly, easy to install, beginner friendly, easy to implement, and those things. And in fact, this will be easy to install too, because we just have to run the plugin process and run the host process, and they will communicate. Okay, so how do we add the plugin to our host? We will just pass the plugin binary to the host. And so there is one con here, and that is language constraint. That is, if we are not using something like gRPC, in which there is no language constraint, then we because we can use different languages. But yeah, so let's talk about Go plugin. So all the pros, all the cons, Go plugin has taken care of, like almost all of them. So plugins are essentially Go interfaces, which is nothing but collection of methods. And cross-language support, we can implement plugins using gRPC. We can implement plugin using RPC too, but if we want cross-language support, then we have to implement uh, the plugins using gRPC. Bidirectional support, both sides can call each other. Now there is one thing that it's only localhost support. I would not say that it is exactly a feature. Right now, a host and a plugin will have to run on the same machine, same local host machine. If they are running on different machines, so say host is running on your machine and plugin is running on some remote machine, then this won't work. It will just give us some unexpected results, some unexpected errors. It is no, the remote support. There is no support for remote plugins right now, and there are so many other features too, like logging and all those things. But these were the most important features that I wanted to talk about. And yeah, okay, let's talk about demo. Okay, yeah, this was the hardest part of this presentation. I just couldn't get this thing right. So let's talk. I have implemented both the gRPC and RPC plugins, but I will go through the gRPC, and RPC is essentially the same. So the core idea behind Go plugin is that it should be as easy as possible. It should be like that plugin is implementing an interface, and the host is consuming that interface. So for example, so let's just go through the code, and this will help you understand it a little more. So what we are doing in this, so okay, we just created a client, and this is RPC client. So it is some you can say it is something related to network. not exactly network, it is related to the plugin, and in that plugin there may be uh, multiple services running, you can say, for example greater service, or maybe some other kind of service, some other kind of methods. So I'm just getting the greater one from that plugin, and the client will be loaded into this room. Now what I am doing is I am basically just converting the interface to the I'm just basically converting the interface to the interface that I have defined. I will cover that interface in a moment. But essentially now what I'm just doing is I'm just calling the method over this greater. That is greater dot read and nothing else. So yeah, it is just you can there are some details related to the plugins, related to the Go plugin, but essentially if you see what it is doing, it is just consuming an interface that is greater. Okay. Yeah. And let's go to the plugin side now. Get this is the plugin side. In plugin side, nothing. We just implement the greater interface and then just pass it uh, to the greater plugin, and everything will be handled for us. And yeah, we are just serving this, and that's it. So this, if you see, this thing will is same for like many different plugins. We just have to implement different implementation for the interface, for the create interface, and we can just change here like hello world or hello name or something. We can just implement that. Essentially here too we only have to implement the interface. Okay. And let's go to the interface. So okay, now the host and the plugin has to talk to each other, right? So they has to agree upon a common language in which they can converse, they can understand each other. So what we are doing is, so this is the interface which both of them has to implement. Not both of them has to implement. The plugin is implementing this interface, and our host is consuming this interface. Okay. And so right as I said that uh, right now this plugin, I had made this plugin to run over gRPC. So I have to create a gRPC client, and I have to create a gRPC server for that. uh, gRPC client will do nothing, but it will just call the like in gRPC what it does, it just call this create method, and it just get a response, and yeah, it just return that response. That's it. And gRPC server, what this thing is doing is it's basically implementing the server for our gRPC, and yeah, okay, and it is just it yeah, it is just implementing the greet method. Like when the client will call this greet method, uh, this greet method will run because of the remote procedure calls. This method will run, and greater plugin. So we define this gRPC client and gRPC server to basically define how gRPC will work, and greater plugin will basically give us the gRPC client and gRPC server. So let's go here. Let's go to main.go. Okay. So I am getting here this greater. Now I have to define somewhere that what this greater is, right? So let's go about this. Yeah, here. I am defining a plugin map, and that plugin map I am defining that okay, if you want to get something related to greater, then you will get this struct greater plugin. Okay. Now what main.go will, what the host will do, it will get that greater plugin. It will use the gRPC client method of that. So gRPC client is doing nothing but returning the client, gRPC client, and that will just call that will just call that method, the greet method. Okay. And now let's come to gRPC server. So this gRPC server will be used by the plugin. Okay. So first we have to basically instantiate. We have to create an instance of greater plugin. So we are just showing that here, shared node greater plugin, and we are just passing it our implementation of the greater interface, and we are just storing it in a map and in the plugins. Now what this will do, this plugin dot serve, it will basically just run an this gRPC server. That's it, and that's how they are basically talking to each other. And all this thing, gRPC server and everything is Go plugin is taking care of all of that. We just have to implement this interfaces. And so as I talk about the language that we have to, first we have to define a language in which they will talk. So this grpc.go file is basically defining that language, and these are the interfaces. These are grpc client, grpc server, gradle plugin, and this file will be shared between the host and the plugin. Plugin will implement the interfaces by using this file, and our host will consume the interface using this file. So this is basically a transfer. You can think of it as, no, not exactly transfer. We are adding all the details about the interfaces and how gRPC will work to this file, this grpc.go file, and it will be shared between all the plugins that are there. Okay, and yeah, so that's it. That's about it. Let me just run this thing. Okay. Let's see. So right now, what it will, okay. Just 1 second, I just ran, RPC one. So I ran the gRPC host program. What it did, okay, it started the plugin started waiting for RPC address. So when our host uh, will start this plugin as a child process, the child process will return its IP address, its protocol, its port on which it is running. It is accepting connection in standard out, and our host will read all those details from the standard out. Standard out is basically nothing. For example, this thing is printed here. You can see it as standard out. That's a very bad way to explain this, but I really don't know how to explain that. So okay, waiting for plugin address, then it connects to that, and yeah, this it calls the greet method. This here, this fmt.print print line greeter.greet. It calls the greet method. The greet method just returns hello, and that's it. After that, there is nothing to do here. It will just stop the plugin, and it will just exit this program. And one more thing that is interesting is, so if we try to run the plugin binary uh, on itself, that is not passing it to some host, then it has been taken care of. So what it will do, it will basically print out, okay, this binary is a plugin. They are not meant to be executed directly. Please execute, yeah, all those things. So how this thing is working? So when we are initiating our client, when we are creating an instance for this client, we are passing it a handshake. So what is this handshake? Let's go to our language language file again, the interfaces. So in this handshake, we define some kind of magic cookie key, magic cookie value, basic plugin and hello, and this thing. So plugin is expecting to get this the magic cookie key and magic cookie value, and then it will know, okay, I got these values and these are matching, so I was called by the right host. Otherwise, it will give a very user friendly error. And that is, if some other host tries to connect with it, that yeah, you are not the yeah. If some other host try to connect with it, that okay, so I am not built for you, something like that. I then try to run that, and if there is no basic plugin and hello, that is when we try to run this like this, /plugin, then it will just, okay, we are not meant to consume directly, and you just use some host that will load this plugin automatically. So that is how Go plugin is working. Yeah. So that, I think that is it. Right. Yeah. Thanks.
All
Okay. So
right.
now,
Does anybody have any questions? Any follow-ups?
All right. So good. All good for now. Something to mention here. I was in the best of ways trying to pick on Shubham and Pratik just to try to help people feel comfortable. In that same vein, I'll say this, that if what Dev presented made sense to more than half of you, then then more than half of you are doing better than I am. Or rather, what I mean to say is, I would be shocked if it made sense to more than half of you. And that's not that's not an insult to anyone. That's the reason I'm saying it is to say there's a couple of reasons why Dev is presenting this. The foremost reason is for each of you. It was for me. It's for each of you. If it's not interesting, don't bother with the questions. But if it's remotely interesting, this is a safe place. Like this is as safe as an open source place as you're going to find to ask what you think are, silly questions, and understand that they're not. I've got about 10 silly questions right now. And so I guess what I'm trying to say is like, please jump in, please ask the silly questions, because that's a large part of the point of why Dev is presenting. It'll help everyone else when you ask the questions. I think I encourage each of you to ask your questions in Slack, like in public channels, for that very point. Like one of the biggest points is because everybody else learns, everybody else has the same question pretty much. So having said that, don't engage, right? You're missing out on the opportunity if you don't ask a question. You have a question. Like one of the things we were, so I provided a lot of context for why you were giving the presentation on Go plugin in the Zoom chat. And as we look at potentially augmenting a remote, the framework that we have for remote providers, potentially with a Go plugin capability, like with something of a standard interface to be able to load in plugins. Well, one of the examples, one of the use cases that we had collectively that we had in mind was the delivery or the use of Go plugin to deliver an additional UI. And the UI, works a little bit differently, doesn't necessarily exchange all of its messages over gRPC. The UI, like if we were to layer in, if a plugin were to be loaded in as at the point in time in which someone signs into Meshery, they choose a provider, they authenticate to that provider, the provider would dynamically load up additional capabilities. It does so today, it just doesn't do it in as dynamic of a way in which you just presented, which is why you're presenting, because we need a better solution. So my question is, if some of those special capabilities provided by different providers, different Meshery providers, are in the UI, do we still have an open challenge around providing a first-class experience with the UI as it's built into the Meshery binary versus a UI potentially running either in a separate process and like the authentication mechanisms that happen between them, kind of the local storage and interface, like basically if we have a separate React app, is it going to feel like a separate app? Maybe you don't have all the answers to this, but
No, actually, I am trying to understand, but I am getting confused by, yeah. So the thing is, okay. So we want to add our front end more pluggable, right?
right.
Okay. So what I get from Go plugin is that it is essentially for the means for the backend. Okay. And so if what I'm getting is we are trying to say that we will add uh, React apps, React pluggable apps that Meshery can use these plugins and then can display something. If I am, I really don't know if that is what you were saying, and I
Yeah, no, yep, that's right. Yeah, that's right. I'm gonna, oh, since this is probably the last topic, I think this is the last scheduled topic that we have, and it's kind of a big one. an intriguing one. Let me make sure that I demo so everyone has the right context as well for the nice presentation you gave, actually. So hopefully everyone is kind of familiar with this page. As you go to spin up Meshery, you go to its UI. Depending upon where you've either deployed Meshery locally on your system, you're running in Docker containers, which is the case for me on the system that I'm on. And I'm using, and so it might be hard for you to see on your screen, I hope not, but the address that I go to, just the default port is localhost 9081. And that gets brought up automatically when you start Meshery. It just pulls open your default browser and points you to the Meshery user interface. If your user doesn't have an authenticated session, Meshery will present you with this provider interfaces, or I'm sorry, with this provider UI to authenticate. You can click to learn a little bit about providers right in the UI here. There's really two functional providers today with two other providers kind of in the works. They're disabled at the moment. So the two that are available today is the default provider called Meshery, and there's another one called None. So when we click on this drop-down list, we see that, hey, what I had just said, which is there's two that are available, two others that are in the works, and the differences between them and the purpose of each of them is kind of articulated, hopefully concisely here. So most people go with the default, and when they do, they get a little bit of an enhanced experience. Let me go with None, which is to say that essentially someone is going to use Meshery and use the baked in local provider. I know the terms are, it doesn't really matter if you get the terms or not. Just the thing that you need to understand is that there's two types of providers. There's two types of ways of logging into Meshery. One is a local provider. The term that we use for it in the UI is called None. So if I choose None, Meshery will just sign me in, and it'll sign me in really as like Meshery at this point kind of turns into a single user mode tool, or like there's sort of this implicit single user that's in there, but it's kind of not. But it's just an anonymous user. It's and so you can use the tool to do various things. When you are in this mode and you've chosen this provider, not all providers are made the same. And so this provider hopefully gives people a compelling user experience that makes Meshery a useful tool to do the various things that they need to do and that they do. One easy way of kind of distinguishing between an example of a difference of user experience that someone might get when they choose between providers is if I've signed in as this anonymous sort of local user, this user doesn't have any performance test results. There's no like history here. They can go run a performance test, and after they do, I guess I won't do it, but after they do, they'll see results here, and they can stop their container, like the storage for persisting and retaining these test results is done locally, local to the container, which also means that, you know, since containers are ephemeral and you might delete one or what have you, like these results will only be around for so long as that container is around. Now, if I were to log out, and if I were to, in this case, if I were to log in with the Meshery provider, so Dev, I'm going over this to both help give everyone context for what's going on, and also then to help re-articulate kind of my question, which I don't know that we'll be able to answer on this, but so if you sign in with Meshery, with the Meshery remote provider, its authentication system gives the user choice of like those 4 different social auths, those 4 different social logins. In this case, I chose my Twitter account, so I logged in, and I've used my Twitter account to log into Meshery a lot. And so when I go to results, I'll end up seeing a bunch of performance test results that have been run. And those are retrieved from the location that's defined, the persistent storage location that's defined by the Meshery remote provider. Anyone can write a provider. And we want to make sure that as people invest in Meshery and use it for all kinds of purposes, that they're able to augment its behavior to their specific use cases. Hence the reason that we have points of extensibility, hence the reason that we have these different providers. And so to enhance that framework, Dev and others are looking at a utility, a library package like Go plugin to be able to take capabilities from a remote provider and plug them in kind of at the time that people authenticate, sort of download those additional packages, those additional capabilities that that provider might have. And it sounded like from Dev's presentation, in this case, those back-end capabilities might be spun up as a process and sitting there available to do whatever the thing is that they were written to do, that the interface that we might use gRPC to interface between Meshery server and those provider plugin processes. To the extent that a provider were to not only include backend processes, backend capabilities to maybe bring support for Nighthawk as a load generator, just as as an example. To the extent that they wanted to, do some, have a new UI, like have another page available. Maybe the page is something like the provider is WePro, a consulting agency, and they'd like to have a new menu item that says, about WePro or service meshes at WePro or something like that. That they can, the framework that we have in Meshery should facilitate for that. It should, when a provider is authenticated to, we should have extensibility in the UI to let people do certain things. Maybe they want to white label Meshery, maybe, I don't know. And so the Dev therein kind of lie part of my example is if we allow people to load in new menu items, when they click on that menu item, it'd be really nice if that wasn't an iframe or a separate external link, but rather that capability is part of the same single page app, like it's part of the same React app. So I've presented the gauntlet. Like I don't know that there's an easy answer to that.
Yeah. So okay. Yeah, there are two things that I think here. One is basically more providers will be coming, and they will be providing authentications and storage of data, essentially that. And another thing is that remote providers will be able to add to the UI itself some new functionalities or something else, right? So there are two things here. So I'm not sure about the UI, that how we are going to do that. Maybe using Go plugin, and I am not even sure that if we can use Go plugin in this case, in the UI case. But for the remote provider, the authentication and the storage of data, we can definitely use Go plugin here. So essentially what a provider has to do, he has to just create a plugin. The plugin will be installed with Meshery in the local machine, and that everything, authentication, data, everything will be sent to that that provider plugin. Okay, it may it depends upon the provider that how they want to implement that, and that plugin will send data to the remote provider, and that's how they can store that data, and that's how they can provide authentication to the user. So that's how I think we can implement pluggable providers that will just give us authentication. And another thing, storage of data. About UI, I am not sure how we can implement this using Go plugin, so I have to see, and maybe I will discuss with like Dhruv or someone else that is working on UI, and we will be able to figure out that okay, this is how we can do that. So yeah, I hope that answer, or is there some emotion or doubt?
With a minute left in the call, let me do two things. One, 3D and Ruth Kaleche, there's a call tomorrow, the newcomers call. I think you guys have been working on a tutorial series. If you can, publish that so that people, judge their interest.
Sure.
And then, thank you. And the other one is a quick call for anyone who's familiar with React. Does anyone know of a similar plugin framework for React? Be able to dynamically pull in new components on the fly.
We need to do some research into it.
Okay. Yeah, good.
All right. Did we want to see the test results from the demo Abhishek gave initially?
Thanks for bringing that up. Actually, it was probably missed in there, but it actually came back and they showed the results kind of in process. So it was successful. That's good.
All right then. I guess that's it for today. Thank you for coming in, everybody. See you next week.
Thanks.
Uh,
Bye, everyone.
Bye.
Bye bye. Bye bye.